afternoon. Today I'm going to talk about this great Desmos activity that I found, and I think it's very helpful for geometry or anyone looking for a task to do for geometry. The standard that we are going to be talking about today is in the Math 2 Unpacking Guide. It is similar right triangles in geometry number, it's 0.8. So it is using geometric ratios and the Pythagorean theorem to solve involving right triangles in terms of content. So as a warm-up, we start and we say, okay class, we just got done talking about this. Can someone tell me which triangle does not belong? As they look, they can see which triangles belong and which ones do not. So if I was a student, I would say, this one is the only one that's a right triangle. So I would pick that one and explain my thinking. Only one that is right triangle. Share my thinking. Other students can share their thinking. It will pop up down here. You can do the teacher moves, which is a great thing in Desmos. If you're actually looking for an activity, they give you things that you can ask yourself while your students work. So after they get done with the warm-up, we're going to move on to this next slide, trying to figure out if this is a right triangle or not. So I would say, okay, you know that a squared plus b squared equals c squared. They can actually use this calculator over here, which is really handy dandy. And they can do 12 plus 6 is 180. And they know that c squared is 169. So you can say, this is not a right triangle. So you'd say, no, not a right triangle. Explain your thinking. Say, a squared plus b squared equals c squared does not equal c squared. You can share that with the class. Other students' responses come down low. As everybody gets done with that, prompt them to move on. Again, the teacher moves are very important. They know that Pythagorean theorem works here. This one is really cool. It gets students to change their values to find which one is what makes a right triangle. It won't let me try it right now, but I'll give you an example. They can do 4 squared plus 6 squared. Okay, that gives you 52. You know by the Pythagorean theorem, if you square root that, you'll find what c is. So c is this. You can also tell them to do, okay, let's change one. Let's say for the left, 4 squared, oops, let's do plus 5 squared. Let's give us a good one. Let's give us one that has a lot. I'm trying to think. Which one gives us a good one? Does this one give us a good one? I'm over here trying to figure it out. Well, not really, but they know that if you put this decimal, they are allowed to use decimals, it will give them, and they can put in their different solutions that they find. So if we do wrong, they can do 6. Let's try it. It's too big, you know. So let's see. tell you to keep drawing until you find one. I tried 8. Does 9 not work? That's too big. I keep playing around with it. I think it actually wants me to change this one. No, not working. So, could actually, if you wanted to, let's see if it allows us to have a decimal. It won't allow us to have a decimal. There you go, they found one that works. So, as they keep making them, they can make different triangles, and like this one, if you changed B to 9, well, you get the idea. So moving on, this one lets them categorize things in groups, saying which is a right triangle, which is not a right triangle. This is very helpful for students that still don't understand and can use Pythagorean theorem a little bit more. Shouldn't take them very long. I'm not really putting them in the right spot, but to show you how it works. And you can see that on your teacher view of how students are putting these as right triangles and which ones are not putting them in right triangles. Actually, I'm pretty sure all of these are opposite. Based on, it's gonna bother me if I don't have it in the right way. It don't want to freaking attach now. Okay, whatever. Moving on. Are you ready for more? They say I'm ready. Every triangle has 3 shapes: acute, obtuse, and right. And it shows you which ones are obtuse and explain your thinking. I really think this is good because you can actually take up this piece of paper as a check-in, or like as a way for are they doing their work. Really important for students to understand. Also, can you tell by the sides of the length? They can do this and explain their thinking and share what parts right. Triangles. And they share with the class, which is really important here. This one is a cool down, maybe like an exit ticket. It shows if this is a right triangle, use the sketch tool to show yes or no, explain your thinking, which I think this is really cool. And then you can rate, maybe I didn't understand, maybe I need some more help. Maybe I need some more help. But in this math lesson, we wanted you to understand why side lengths satisfy a squared plus b squared equals c squared, and then determine whether a triangle is a right triangle based on its side lengths. I think this is a great lesson, and I would love to use it in my classroom. Thanks so much for listening.